The weather isn't always sunny, and sometimes that means we're stuck inside. But if you're staying home and wondering more about what is causing the weather outside, we have just the thing for you. If you know someone young, or young at heart, who is curious about the atmosphere, we have a few ideas for some activities that will teach them more about the world around them, all while having some fun in the process. The best part is, they can all be done from the comfort of your own home. First, we're going to learn a little something about fronts. What actually happens along a cold front, and how do they produce precipitation?
To do this at home, you'll need some type of box or bowl like I have here with a divider in the middle. You'll need water, and I filled it up so it's equal height water on both sides, 2 different types of food coloring, and you'll need some salt. First, what I'm going to do is I'm going to mix salt into half of the water on one side of the box. So I'm going to just pour some salt in here. Don't be afraid to use a good amount. Take a spoon, stir it up, make sure all the salt in the water is dissolved. So now we have one side of the box that has salty water and one side that has fresh water. Now we're going to take our food coloring. First, I'm going to take the blue food coloring here. I'm going to use this to represent cold air in our atmosphere. Just a few drops in each side works out wonderfully. And on the freshwater side, we're going to be using red food coloring. That's going to represent warm air in our atmosphere. Because after all, our atmosphere is a fluid. You may not know that. We'll stir them up a little bit so they're nice and even in color here. Now, we have our salty blue water on this side and the red water without salt in it on this side. Now, what do you think is going to happen when I lift the divider in the middle? Let's find out. Notice the water starting to mix, but it's not blending together. Instead, the blue water is falling to the bottom of the tank, and the red water is falling to the top of the tank. It's even creating a little bit of a circulation in the middle there.
Why does the blue, salty water slip under the red water? The answer is density. The salt water is more dense than the water without salt, so it sinks to the bottom and pushes the red water to the top. This happens along cold fronts as well. Cold, dense air tends to slip under warmer, less dense air. This in turn causes warmer air to rise, which often generates the precipitation we see along cold fronts. Warm fronts work a little differently, but still rely along the concepts of density. But temperature doesn't just affect density, it also affects air pressure. Now, let's see this in action with a soda can. Do you think we can use the power of air pressure to crush it?
To do this experiment, you'll need a soda can that's filled up with just a little bit of water, a hot plate or stove, a tray or a bowl that's filled with cold water, and some tongs. So now that we have our can with the water in it, and it's nice and hot, we know because we can hear it bubbling a little bit in the can, and we can also see some of the steam coming up through the hole of the lid of the can. What we're going to do is we're going to take the can with the hot water inside of it, we're going to flip it over into the tray that has the cold water inside of it, and we're going to see what happens. So we'll grip the can with our tongs here, and did you hear that? The can actually crushed a little bit when I put it there in the cold water. And the reason for that is air pressure. And check this out too. When I flipped the can over, there was only a little bit of water inside of the can. But now, look at all the water inside the can. The area of low pressure that was created inside the can actually sucked up cool water into it when it was flipped over.
We just used the power of air pressure to crush that can. But what else can changes in temperature do with water vapor? If you live in or near one of Pennsylvania's many valleys, you probably see fog frequently. But did you know that you can create fog right in your own home?
To do this experiment, you'll need a container or jar filled about halfway with hot water. And we actually microwaved the water, so it was nice and hot. You'll also need some hairspray, a plate or some type of lid to put on top of the jar, and some ice. So what we're going to do is we're actually going to take the hairspray and we're going to spray it inside the hot jar there. And then we are going to place the lid with the ice on top and see what happens over time. Now, if you take off the lid, do you notice fog coming out of the jar? And this fog is the exact same fog that you see maybe when you step out the door in the morning.
Fog began to form in the jar because the ice on top of the jar cooled the warm water vapor, causing it to condense or change from vapor to small water droplets. Think about when you tend to see fog. It's a warm day followed by a cool, clear night. A cool, clear night is almost like putting the ice on top of the jar and allows the water vapor near the ground to condense into droplets, which forms a cloud at the surface.
Ultimately, our 3 experiments today boil down to 2 factors that influence all of our weather on Earth: changes in temperature and the presence of water vapor. We hope we've made you learn a little bit more about the atmosphere and the world around you while having some fun in the process in your own home. For Weather World, I'm student meteorologist Tyler Hughes.